In this lesson, we're going to review relative frequency, and we'll be looking at theoretical and experimental probability as well. Again, relative frequency is the ratio of observed outcomes over total outcomes. In this example chart here, we are showing the amount of vehicles that pass through an intersection. There are 160 total vehicles that pass through that intersection. Of that 160, 108 were cars, 12 motorcycles, 16 vans, and 24 trucks. Our relative frequency for cars was 108 over 160, which could reduce to 27 over 40. If we wanted to write this as a decimal, that would be 675 thousandths. For motorcycles, it was 12 out of 160, which reduces to 3 out of 40. And that would be, as a decimal, 75 thousandths. 16 out of 160 vans reduces to 1/10. And then our trucks, 24 out of 160, would reduce to 3 out of 20, which is 15 hundredths. We could change all of these to percents by multiplying by 100. So a car would be 67.5%. Our motorcycle would be 7.5%. 10% for van, and 15% for truck. And if I added all of the percents, I would get 100%. If I added all of these decimals, I would get 1. We could use our relative frequencies to make predictions. If we were to ask which vehicle is most likely to pass through the intersection next, we would probably say car, about a 67.5% chance of passing. The least likely vehicle to pass through that intersection would be a motorcycle at 7.5%. For this problem, we see that Lauren turned the spinner 200 times and recorded the letter that the pointer landed on. The observed frequencies are summarized below. So if we look at this spinner, we notice that all look to be equal. So A, B, C, D, and E are all equal. So if we were looking at our theoretical probability, the theoretical probability of landing on A would be 1 out of 5, or a 20% chance. Same with B. Same with C. Same with D. And same with E. So what that is saying in theory is if I spun this 5 times, I should land on A once, I should land on B once, C once, D once, and E once. We know, though, that's more unlikely to occur than it says in theory. So as we spin this, we get an experimental probability. And we could use our observed frequency to determine what our experimental probability is. So we look for how many times it did occur in an experiment over the total times we spun that spinner. If we were to spin this 5 times, we might end up getting A 3 out of the 5 times. That means it would be a 60% chance of landing on A, but theoretically we know it shouldn't be. It's 20%, but through that experiment, it would show a 60. The more times that we practice this experiment, the closer we should get to our theoretical probability. So if we spun it 10 times, maybe we get the 3 A's, then we get some B's and C's in there. If we do it 100, the numbers might change. This table is showing us 200 times. If we do it 1,000 times, our numbers may look closer to 200 in each of these. So the more times we do this experiment, the closer we should get to our theoretical probability. Using our observed frequencies, we're going to figure out what our experimental probability was for spinning the spinner 200 times. So if we start with A, that was 36 out of 200. As a decimal, that would be 18 hundredths. And as a percent, that is 18%. Looking at B, that was 44 out of 200, which is 22 hundredths, or 22%. If we look at C, that occurred 28 out of 200 times, which is 14 hundredths, or 14%. D was 52 out of 200, which is 26 hundredths, or 26%. And E occurred 40 out of 200 times, which is 2/10, or 20%. So based off of our observed frequencies, we could find our experimental probability, or the likelihood that these events would occur. And we could answer some questions about it. We could say that if we spun the spinner one more time, we could make an educated guess saying that D would land next. Based off of D being 26% of the time, we would say that D is most likely to occur out of these chances. The least likely to occur would be C at 14%. So we could use our observed frequency. We could use our observed frequency to get our experimental probability, and then we can make inferences based off of what we collected in our data. You'll notice as we spun it too, they're all pretty close to 20%. E landed exactly at its theoretical probability, but D, C, B, and A aren't that far off. And I would say that if we spun it 800 more times, these numbers would probably shrink and get closer to that theoretical probability of 20%.